Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from limits, right, involving the greatest integer function, right. So here we have to find the value of this limit, that is limit x tends to 1 plus. This positive sign shows that we have to find the right hand limit of this function, right, when x approaches to 1. So here the function is e raised to 1 minus x plus greatest integer of x minus 1 plus greatest integer of 1 minus x, right. So here e is the exponential number. So let us start. Now see, here we have to find the right hand limit of this function when x approaches to 1 from the right of x is equal to 1, right. So we'll take a point in the right neighborhood of x is equal to 1, that is 1 plus h, right. So we'll take x is equal to 1 plus h. So we'll make this substitution where h is a very small quantity, and when x approaches to 1, then h approaches to 0, right. And here h is a positive quantity, and moreover h lies between 0 and 1, right. So we'll make use of these results to get the value of this limit, right. So let us call this limit as L, right. So now what we will do, we'll transform this limit in terms of h. So now we can write L is equal to limit, and here x tends to 1 positive can be written as h tends to 0, right. And we have e raised to, see here we have 1 minus x, so we can write 1 minus, for x we can write 1 plus h, and then we have greatest integer of x minus 1, so x can be written as 1 plus h minus 1. This is minus 1, and then we have greatest integer of 1 minus, for x we can write 1 plus h, right. Okay, so now we have to simplify this expression. So now we can write a limit h tends to 0, and here we have e raised to 1 minus 1 minus h, and here we have 1 and 1 get cancelled, so we are left with greatest integer of h, and here we have 1 minus 1 is 0, so we are left with minus h, right. Okay, so now this one and this one get cancelled, so we are left with limit h tends to 0, and we have e raised to minus h plus greatest integer of h plus here we have greatest integer of minus h, right. So now see, here we have two terms involving the greatest integer function, right. Now see, we have h, uh, it lies between 0 and 1, right. So h is a very small quantity which lies between 0 and 1. So by definition of greatest integer function, the value of greatest integer of h must be equal to 0. So here we can write 0, right. And when limit h tends to 0, this h also goes to 0, right. And see, here we have greatest integer of minus h, right. Now see, if we multiply throughout this inequality by minus 1, we'll get 0. The direction of the inequality get reversed, so we have minus h, and here we have minus 1, right. So we can write this inequality as minus 1 and minus h and 0, right. So this indicates that minus h, it lies between minus 1 and 0, right. So this is minus 1, this is 0. So minus h, it lies somewhere between minus 1 and 0. So therefore the greatest integer of minus h must be equal to minus 1, right. So this quantity is minus 1, right. So now see, we have e raised to, here we have minus 0 because h tends to 0, and here the greatest integer of h is 0, and here greatest integer of minus h is minus 1, right? So overall we'll get e raised to minus 1, that is 1 over e, that is the reciprocal of the exponential number, right? So the value of this limit is equal to 1 over e, that is e raised to minus 1, right? So this is how by the concept of greatest integer function we can evaluate these type of limits.